Okay, we're going to get a little more practice and work a little more with some of the problems or word problems that you can see with square roots or cube roots. So to start with, we're going to do a couple things that might help us a little bit. So I'm giving you a sheet. The sheet has a couple tables on it. We're going to get everything kind of just on one sheet. Let's keep things a little organized. So we're going to start with squares. So on the sheets I'm giving you, this is the top left side. And what you're supposed to know as 8th graders are basically your perfect squares all the way up to 20 squared. So we got to be able to do any one of these all the way up to 20 squared. Anybody remember from earlier in the week what 20 squared was? 400. We got 400 there. And what's 1 squared? 1. All right, so we got to fill in the rest. Y'all go ahead, start filling those in. 2 through 19. The state says we got to know all the way up to the square root of 400. That means anything from 1 to 20 squared could be on your EOG or on your check-ins. Who can raise their hand and give me 2 squared? 4 is correct. About 3 squared. Ethan. 9's correct. 4 squared. Keller. 16's correct. 5 squared. Taquan. 25's correct. 6 squared. Samantha. 36 is correct. 7 squared. Adam. 49's correct. 8 squared. Carlea. 64 is correct. 9 squared. Nevea. 81's correct. 10 squared. Caden. 100's correct. All right, that's the easy side. Hopefully on this side, you should know those without really having to work them out too much, right? Other side, or the bottom half on yours, because it's just one big list on your paper, a little tougher. Who can give me 11 squared? Nevea? 121's correct. 12 squared? Keller? 144. 13 squared. Anyone got 13? 13 squared, 13 times 13 is 169. 14 squared, 14 times 14, 196. 15 squared is 225. 16 squared $256. 17 squared, so 17 times 17. These maybe don't follow a pattern, but they do get higher as you go, right? So we gotta keep getting higher numbers. It can't be anything lower than 256. So $289. All right, 18 times 18 is 324. 19 times 19 is 361. Once we get kind of over 15, those are ones where, you know, I need to write them down even a little bit to work them out. And you don't automatically know them. You won't see those as often, but since the state says up to 20, there is a chance you could see those, okay? Any questions on that? All right, so just so everything's on the same sheet and the same page, we're going to do the perfect cubes also. You already have a similar table. So what's 1 cubed? 1. What's 10 cubed? 1,000. 10 times 10 times 10 makes 1,000. All right, anybody remember what 2 cubed is? Nevaeh? 2 cubed is 8. 2 times 2 is 4, times 2 is 8. Ethan, you got 3? 27's correct. 4, Aubrey. 64 is correct. Anybody remember the 5, Adam? 125 is correct. How about the 6? Nevaeh? 216 is correct. The 7. Ethan? 343 is correct. 8. Nick? No. Adam? 512. 9. Nevaeh? That's the 729, is 9 cubed. All right, so like I said, you basically already have that list on the other sheet of paper, but this way they're just all in one sheet, so you don't have to kind of like shuffle around or anything. As we saw yesterday, and this can be a little bit helpful, right? The state actually says for the cubes, you only have to know up to 400 also. So up to 400 cuts off 8, 9, and 10. 10's easy though. And just to get good practice with it, we still use 8, 9, 10 in class, okay? So you'll probably see 7 or lower only for the cube roots. All right, one of the other things we have to be able to do is solve some equations with these. When you solve equations, you do the opposite, right? And we follow our order of operations backwards. You know, instead of please excuse my dear Aunt Sally, it's Sally Aunt, dear my excuse please, right? We get rid of subtraction or addition first by doing opposite. So if I take this one here, I subtract 7. If I do it from one side, same thing to the other side. So we want to cancel it out. We want to get the variable by itself. So I've got x squared, and then that will equal, in this case, 225. And then we're still doing opposite. Exponent, so that's towards the end. There's no multiplication or division in this problem, but if there were, we would do that before exponents too. We get rid of exponents by taking the roots. If it's a 2 for the exponent, we take the square root. What's the square root of 225? 15. And remember, with square roots, it's that plus or minus 15, right? Okay? Any questions on that one? Do the one below it too. That's number 3 on your sheet. So what's the opposite of subtraction? Adding. So we're going to add 8. Oh, and I messed up the numbers. My fault. I need to switch that one. Is that what's on your sheet too? Oh, we need to change that. Change that to a 56, okay? So when I have the 56, now I'm adding 8 to that. So I got x cubed equals 4. And we take the cube root. Since it was to the 3rd power, we do the cube root. What's the cube root of 64?
8.
4. Cube root is 4. Do we do plus or minus for cube roots? No, it's just one or the other, okay? Any questions on either? All right, y'all go ahead and do the other two, okay? All right, who's got this top right one? That's number 2 on your sheet. Jaden? 3 is correct. We subtract 6. So we get x cubed equals 27. We take the cube root. So cube root of 27 is 3. Last one. Connor? 8 is correct. Add 9. So we get x squared equals 4. We take square root. That's x equals 8. But remember, plus or minus 8 for the square roots. All right, Any questions on those? Little bit more to it, right? But it shouldn't be anything that's like super difficult to do. You just got to do that one step with the addition or subtraction. All right, go ahead and flip your sheet over. Got a few problems on that side. A few word problems. Sometimes you see these with word problems. So first one here says the area of the square is 121 square inches. What is its side length? 11's correct. All right, so Carlea took the square root of 121. That's how she got 11. How do we know to take the square root? It wants to know the side length. All right, a couple things we can look at. Since it's asking for the side length, we know in that regard that that's doing some sort of root, okay? Then I heard each of you, one of you said we got exponent of 2, the square inches, and then just the fact that it's a square, or the area, that's where you're taking square root. Everybody clear on that? So if you see the word square and exponent of 2 and it's asking for the side length, you're going to do the square root. So similar, second one here, if the volume of a cube is 343 cubic inches, what is its side length? Nevaeh? 7 inches is correct. So, whoops. What she did here, she took the cube root of 343. What's telling us to do the cube root? It's a cube, and we got a little exponent of 3 on our label, right? And it's asking for side length, so we know we're doing some sort of root. Okay? Everybody good on those? They're not tough. It's just you got to figure out, you got to make sure you're doing the correct one. Especially if they gave us a 64, you know, that works for both of them. All right, so this third one here. Rihanna uses 49 1-inch tiles to make her square mosaic. What is the length of one side of her mosaic? Jaden? 7. How do we know to do the square root here? Yeah, it says it's a square. So what you have is, if anybody not know what a mosaic is? So basically what a mosaic is you have like tiles, and they take the tiles, they might be like different colors, and they put them together to make a picture. So if it's a square, what she's doing is she's taking a bunch of smaller squares and making a picture. Make sense? At least a little bit? I'm not an art teacher, so that's not the probably best definition of it, but that's basically what it is. So we have a bunch of squares making a bigger square. That's like the area, and we take square root. All right, Ronnie's largest wooden box has a volume of 1,000 cubic inches. What is the side length of the box? Taquan? Huh? 10's correct. So what he did is he took the cube root of 1,000, that got 10. How do we know cube root? Cubic isn't exactly the word cube, but that's what it means, okay? So if you see cubic inches, that's kind of like, you know, with square inches, it's just slightly different wording on it, okay? Just how English works. Any questions on any of those? Like I said, this stuff still shouldn't be anything super difficult. having those lists probably will help too.